Today we're graphing step functions. So if you look at the picture here, a step function graph represents a set of stair steps. Look at that. Ooh. Step functions are piecewise functions, which we're going to talk more about tomorrow. So if you look, this is kind of how it's going to look. We got f of x equals 3 if x is less than 2, and f of x is negative 2 if x is greater than 2. What? So f of x, remember, is the same as y. So basically they're saying y is going to equal 3 if x is less than 2, and y is going to equal negative 2 if x is greater than or equal to 2. So what I do is I kind of create a boundary line. If x equals 2, that would be a vertical line at 2. So what I do is I create like an invisible wall there at x equals 2. Is this necessary? No, of course not. But this helps me picture kind of what's going on. So if x is less than 2, aka if it's to the left of this line, y is going to equal positive 3. If you just graphed the equation y equals 3, it would be a flat line at 3. So to the left of this line, we're going to be at positive 3, which would be a flat line, and it goes on forever. Cool. But when x is greater than or equal to 2, to the right of this line, y is going to equal negative 2. So that would be a flat line at negative 2. That's pretty much it. Now there's one other thing, like what if it's exactly 2? Which line would it jump to? And that's where the or equal to's come into play. So we're going to create like almost dots at the end. Whichever one has the or equal to, kind of like when we were graphing the inequalities before, would get a solid dot. So the negative 2 is the one where it has the or equal to. So this would get a solid dot on the end of it, meaning like if it was exactly 2, it would be on this line. So if it's not on this top line, we can create like an open hole at the end of it, like an open dot. So the or equal to's get the solid dot at the end. It's pretty not bad. It's not too challenging. So let's try some more. All right, cool. Now if you look here, we have a range from negative 4 to 2. We have one from 2 to 4 and 4 to 8. So we're going to draw some boundary lines at negative 4. 1, 2, 3, 4. We're also going to have one at positive 2. And positive 4 and positive 8. And again, these wouldn't really show up on like if you typed it into a computer program, these wouldn't show up. But these are like kind of our invisible walls that we have to remember. There's going to be a line here, and then it's going to change to a different line in this chunk of the graph. So between negative 4 and 2, our y is going to equal 3. So we're going to have a flat line at 3. Whoop. We'll come back and get the dots at the end. The next chunk, between 2 and 4, we're going to be at 2. Boop, flat line at 2. And then in that last chunk from 4 to 8, we're going to be at positive 8. So that would be all the way up here. Great. Now remember, the or equal to's get a solid dot. So if you look at the 3 up here, it was negative 4 is less than, so that would get an open dot at negative 4. And the less than or equal to 2, so it's going to have a solid dot on the 2. Cool. In the green zone from 2 to 4, its 2 is less than x, so it's going to have an open dot here, which makes sense because it has a solid dot right above it. And then once it gets to 4, it's got the or equal to, so it's going to have a solid dot at the end of that one. And then we're jumping up to the 8. And so it's 4 is less than x is less than or equal to 8. So it's going to be an open dot on the 4, but a closed dot on the 8. Again, not too bad, right? It's flat lines at those numbers. The dots can be the toughest spot, but just fill in the dot when it's an or equal to. So we're going from 0 to 1, 1 to 2, 2 to 3, 3 to 4. 0 to 1 to 2. You know what? I'm not even going to draw the invisible lines here. They're all just one after another. So from 0 to 1, we're going to be at 1. 0 to 1 would just be right there. Then from 1 to 2, we're going to 2. Okay. All right. Not too exciting. From 2 to 3, we're going to be at 3. Whoop. And then from 3 to 4, we're going to be at 4. Wow, that's really exciting. So if you look, 0 has the or equal to, so that would get the solid dot there. The 1 is just less than, so that would get an open dot. All right, in the next chunk, 1 is the or equal to, so that would get the solid dot. 2 is going to be an open dot. 3, it's kind of got the same pattern. 2 is going to have the or equal to, so it's going to have this solid dot. 3 is going to be an open dot. And the last one, 3 is less than or equal to x, so 3 would have the closed dot, 4 would have the open dot. That's a cute little graph right there. Super cute. Ooh, all right, we're going from -4 to 4. All right, all right. So I'm going to give myself an invisible vertical line at -4 and +4. 1, 2, 3, 4. All right, we're ready to go. So if we are less than or equal to -4, to the left of -4, and also I notice it's or equal to, so it'll get a solid dot, we're going to be at 5. So a flat line at 5. 1, 2, 3, 4, 5. And it's going to have a solid dot on the end of it because it's the or equal to. Once we get from -4 to +4, we're going to be at 2. Now you'll notice neither of those have an or equals to. So they're both going to end in open dots. So a flat line at 2, open dots at both ends of that. Wow, fun! And the last one, we're going to -1 for when x is greater than or equal to 4. Or equal to, solid dot. So we're at -1, solid dot, and everything greater than 4. To the right. Great. I think I might have one for you to try. Ooh, that would be fun. Oh, no. All right, so this was the old day 2 notes. We're just going to keep cruising here. We're doing the step functions. It's all the same. All right, if you look at this, we've got a range from -4 to -2. So I'm going to give myself a wall at -4, -2. I see the next chunk is 0, then 2, then 4. So it's every 2 spaces we're going to have a change in the graph. All right, cool. So between -4 and -2, we're going to be at 2. Now the -2 has the or equal to on it, so that's going to have a solid dot. The -4 does not, so that's going to be an open dot. The next chunk from -2 to 0, we're going to be at 5. 1, 2, 3, 4, 5. The 0 is going to have the or equal to, so that'll have a solid dot. The -2 does not, so that'll be an open dot. So that one's handled. Now we're going to 7. From 0 to 2, we're going to be at 7. 0 has just the less than, so that would be an open dot. 2 has the or equal to, so that would be a filled in dot. And the last one, we're going all the way up to 10. 2 is less than x, open dot. Less than or equal to 4, closed dot. Great. To give you an idea of where we're going next, because we used to do the piecewise functions first, this is kind of where we're going from here. So these were nice. They were just flat lines at that number. But now we're going to have, if x is less than or equal to -1, here's our dividing line. So if it's to the left of this, we're graphing the line y equals 2x plus 5. Now we've done that. That's slope-intercept form. So ordinarily, you would go up 5, 1, 2, 3, 4, 5, and then you would go up 2 over 1. This would be a straight line through there. But we're only graphing the portion of this line that is less than -1. So we're going to kind of have to, you could draw the full line and then erase the stuff to the right, or you can kind of just fill in the dots of the line. So if the slope is 2, you could go up 2, right 1. You could also go down 2, left 1, down 2, left 1. We only want the portion of this line that is less than -1. So that would be the stuff to the left of the line. The stuff to the right? Nah. Now that was also less than or equal to. So that would get a solid dot on the end of that. Now, once we're greater than -1, we're just having a flat line at 2. So a flat line at 2, woo! There it is, with an open dot on the end. That's where we're going from here. So it was nice. They were just standard numbers, flat line at that number. That's where we're at today. This is where we're going tomorrow. All right, let's see what else we got. Ooh, write a step function from the graph. So let's kind of look at the dividing line here. I see it's changing over at 1. So we'll say f of x equals, and then we kind of do that fun parentheses. So if you look at 1, this line here, it's at 2, but that's if x is, and it's got an open dot, so that would just be less than 1. Now, once it becomes greater than or equal to 1, because it has a solid dot, if x is greater than or equal to 1, then it jumps all the way up to 4. Look at that. We just wrote ourselves a step function. How cute is that? All right. Now, if you look, this one's a little trickier. So we have dividing lines at -2. We also have it change over at 3. So let's say f of x equals, cool parentheses. I see we're going to have a line at -1. We're going to have one at +1. And we're going to have it jump up to 3 over there. So if x, well, all right. So it's going to be at -1 down here. I see our dividing line is at -2, and it's got an open dot there. So that would say just less than -2. Now, when we're in the range between -2 and +3, let's see, -2, x, +3. The -2 has a solid dot on it, so that would be less than or equal to. The 3 has an open dot on it, so that would just be a less than. And then the last one, once it gets to 3 and beyond, it's got a solid dot. So that would be if x is greater than or equal to 3. I believe, if I remember correctly, there's one for you to try here. Nope. The brain is old and brittle. I can't remember, guys. That's it.